Okay, so we are going to learn about reciprocal functions today, which is basically rational functions, a special type of rational function. And then we're going to be introduced to graphing and all that fun stuff. So before we do that, let's do this little do now. Find the domain of each of these functions. Um, so to find the domain, you have to set your denominator equal to 0 or not equal to 0, right? So we always start with all real numbers. But then, let me rewrite that, all real numbers, but then x cannot equal what? So I take my denominator, which is 3x minus 6, and I'm going to set it, so 3x minus 6, I'm going to set, hold on, I'm going to set equal to 0, so I find out what values of x make my denominator equal to 0. And so I get 3x equals, I add 6, I divide by 3, and I get x equals, if I divide by 3, on both sides, I get x equals 2. X equals 2. So my domain is going to be all real numbers, but x cannot equal 2. Again, because if you plug 2 in, you get 2 over, if I plug 2 in, I get 6 minus 6, which is 0. I get 2 over 0. That is undefined. You cannot do 2 over 0. So that is my domain. And then we have y equals this function right here. So same concept. Let's make some room. Same concept. So I want to take the numerator is completely irrelevant to my domain. So what I'm going to do is I'm going to take 2x squared plus 4x minus 6. And I need to solve for x. So I need to factor it. Always the first step in factoring. What is it? It is always going to be to take out the GCF. The GCF for this is going to be 2. So it's going to be x squared plus 2x minus 3. And then I keep going. It's not fully factored. And I can do reverse FOIL here. So I have 2. And then if I do reverse FOIL, I get x and x. And what two numbers multiply to -3 and add to +2? It's going to be +3 and -1. So then I take this and I set it equal to 0 and I solve. And when I solve, I'm going to use my t-chart and set each of my factors equal to 0. Your GCF, technically your GCF is a factor because it is called the greatest common factor, right? GCF stands for greatest common factor. However, will 2 ever equal 0? No. So it doesn't make a difference when it's a 2. If this was an x, for example, then yes, it would make a difference and x could equal 0. But 2 is never going to equal 0, so it makes no difference in the long run. So this doesn't matter, right? But this does. So here I get x equals, it's probably not a good idea to put an x here, but x equals -3 and x equals +1. So my domain is going to be all real numbers, but x cannot equal -3 and +1. How can I check the work? Well, I can plug these in and make sure I get 0 in the denominator, because that is what's going to make it undefined. All right, so the question is now, what does it mean if something is not included in the domain? What does that mean at all? Like what? Yes, we know that it makes the function undefined, but what that means is that it cannot, the graph of that function. So if I have a function and at x equal, and let's say the domain is r equals, all real numbers except x cannot equal 1, right? This cannot be the graph of the function because here at 1, the function exists. So we are going to talk about it, like what happens graphically in a little bit. But what we need to know is that the domain tells us that the function is undefined at that x value. meaning the graph cannot cross that x value. So that's important here when we're talking about graphically, what does the domain mean? Okay, so let's talk about this thing called a reciprocal function. So a reciprocal function is, so basically our parent function, our most basic parent function is y equals x, right? That's linear. The reciprocal of x is 1 over x. So we have what we call the parent reciprocal function. Okay, but by general definition, right, because y equals x is not every single linear function, right? It's just the parent linear function. So y equals 1 over x is not all reciprocal functions, it is the parent reciprocal function. So what is a reciprocal function? Well, it's any equation in the form of 1 over a to the x, where a to the x is linear, so it has its first degree, and it can't be 0, right? And there's a constant in the numerator. So constant in the numerator. And we are going to talk about it later on. We're going to be able to add numbers to it later on. But for right now, this is at its most basic definition. Y equals 1 over a linear function. Okay? Now, this is what the graph of a reciprocal function looks like. So what if I have, this is my parent function, right? So let's come down here. If I have y equals 1 over x, again, this is my parent function, right? The same way with quadratics, my parent function was y equals x squared. With linears, y equals x. With cubic, y equals x cubed. With, right, square root of x. It's the most basic of that function. Okay, these are all parent functions. This is the parent function of a reciprocal function, right? I'll just say these are parents. Other parents. Now, what is the domain of this function? That's the question. The domain of this function is all real numbers, but what value of x will give me a 0 in the denominator? Well, x cannot equal 0, right? Now, also, our range, I'm going to tell you the range, and then I'm going to explain why that is the range. The range is going to also be all real numbers, but y cannot equal 0. The reason that this is the case is because, is there a value for x when I plug any number in that's going to output 0, right? If I plug in a positive number, like 3, I get 1/3. If I plug in a negative number, like -3, I get -1/3, right? If I plug in 1, I get 1 over 1, which is 1. If I plug in, let's say, a fraction, 1/2. 1 over 1/2 is 1 times 2 over 1, which is 2. So is there a value that when I plug it into the denominator, I will get 1 over x equals 0? The answer is no. The question is why. Why is it that 1 over x can never equal 0? Well, let's say we have 1 over x equals 0 and we solve for x. What would I do? I would multiply it by x, technically, right? To get the x by itself. I want to get the x by itself. And I get x, 1 equals 0 times x. What is 0 times x? 0. I get 1 equals 0. Is this a true statement? No. This is not. So therefore, this is not true. And that means that this cannot be true. So y equals 0 will never exist. So therefore, it is not in my range. So what this means is that when we graph this function, right, if I have right here, when I graph this function, I have, and we've spoken about asymptotes before, when I have a restriction on my domain or my range, that means I have an asymptote at that value for right now, until we talk. It gets deeper later on, but for reciprocal functions alone, just for reciprocal functions, this is the general rule of thumb. I have an asymptote at x equals 0, and x equals 0 is my x-axis, my y-axis, I mean, and I have an asymptote at x equals 0. And so my parent function looks like this. Now, we are going to do transformations on this function. But before we do those transformations, I want you guys to understand that the asymptotes exist. Now, when we move this function, the asymptotes are going to also move with the function, just like it did when we worked with exponential functions, right? When we worked with exponential functions, right, vertical asymptotes and horizontal asymptotes. But when we had an exponential function, we would have a horizontal asymptote and my function would look something like that. It looks similar, right, to this. But what's important here is that with exponential functions, there were no vertical asymptotes. It was just a horizontal asymptote. So what we know about asymptotes, and we've defined this, is it infinitely gets closer, but does not touch. Can't touch this. Da-na-na-na. Da-na. Da-na. Can't touch this. Da-na-na-na. Da-na. Do you guys miss my singing? Same, me too. Okay, and then the next video, we're going to talk about actually graphing reciprocal functions and transforming them.